Embry-Riddle Aeronautical University, Daytona Beach, won second place in the 2021-2022 International Design Build Fly competition hosted by the American Institute of Aeronautics and Astronautics. This is the Medical Unmanned Low-Level Electric Transport, also known as MULLET. MULLET was the highest performing aircraft at the fly-off in Wichita, Kansas. Design Build Fly is an annual aircraft design competition aimed at giving students a hands-on way to apply their engineering studies. With nearly 100 universities participating from around the world, each year brings a new mission profile and a fresh set of design challenges to solve. Our team consisted of 40 undergraduate aerospace engineering students who worked over 9,000 man-hours on this project. The 2021-2022 mission profile was a humanitarian one, with 3 flight missions and 1 ground mission. Mission 1 was a deployment flight to demonstrate the aircraft's ability to fly. Mission 2 was a staging flight for the transportation of vaccine syringes. The aircraft was scored on how many syringes could be carried, and its time to complete 3 laps of the 1,000-foot pattern. Mission 3 was a delivery flight in which the aircraft had 10 minutes to fly as many laps as possible, landing to deploy 1 vaccine vial package on the ground each lap before stopping to take off again. The vaccine vial packages had 25G sensors on them, such that they had to be deployed safely to the ground without tripping the sensors. The ground mission was an operational demonstration of the ability to prepare the aircraft for flight in a timely manner. Some of the primary constraints on the aircraft included a 25-foot takeoff limit for all takeoffs, a maximum linear dimension of 8 feet, and a propulsion battery power limit of 100 watt-hours. The previously explained requirements were released on September 2, 2021. The 5-person engineering design team, who received course credit for designing the airplane, completed a scoring analysis to determine the optimal payload to carry within the first 2 days. The conceptual and preliminary design phases were then completed in 4 weeks, during which a conventional low-wing tractor configuration was selected. The aircraft was sized to carry the optimal payload while balancing each mission's performance to achieve the greatest possible score. During this design phase, it was quickly determined that the takeoff distance was the primary constraint on the aircraft. For this reason, a full-scale semi-span wing model was tested in Embry-Riddle's new low-speed wind tunnel facility. It was confirmed that the wing produced adequate lift for the takeoff and cruise conditions. Over the next 2 weeks, the detail and product design phases were carried out to produce a full computer-aided design model of the aircraft. This model was used to manufacture the aircraft in 3 weeks, ultimately yielding a first test flight just 9 weeks after the requirements were released. Some key features of the design included a semi-monocoque structure that provided the necessary strength while reducing weight wherever possible, and interchangeable wings, tails, and fuselage that allowed for iterative design and manufacturing. In the meantime, 2 subsystems to carry the vaccine syringes and deploy the vaccine vial packages were being developed in conjunction with the aircraft prototype. Flight testing on Iteration 1 began with the primary objective of validating the flight and handling qualities of the design. In addition, the takeoff and landing performance was evaluated early to ensure the design could meet all mission requirements. However, the aircraft suffered a critical structural failure while testing its stall performance on its 8th flight that resulted in a total loss of the airframe. This crash was traced back to a failure in the wing carry-through, the primary structure that connects the wings to each other and secures them to the fuselage. All lift loads pass through this structure. During the flight in question, the pilot pulled nearly 4 Gs while recovering from the stall, which caused the wing carry-through to fracture. As a result of the crash, and given the timing relative to winter break, the team opted to spend the remaining weeks of the fall semester working on the payload subsystems while the wing carry-through was redesigned. Subsystem prototypes were tested first with a foam mock-up of the fuselage, and then with an actual version of a new fuselage. The vaccine vial package deployment mechanism featured a conveyor belt and a door slide. The conveyor belt adhered the vial packages to secure them in flight, and moved them aft to release them onto the door slide. After deploying each vial package, the belt returned the remaining vial packages forward to maintain a constant center of gravity, critical for aircraft stability. The door slide served to deliver the vial packages from the conveyor belt to the ground. The top of the slide was contoured to provide a smooth transition to the ground, while the bottom was contoured to match the outer mold line of the tail for improved aerodynamics. The vaccine syringe storage mechanism featured 2 fabric bags, one in the front payload bay and one in the aft, that stored the syringes, restrained them from shifting in flight, and allowed for quick unloading in the ground mission. Meanwhile, the flight test team stayed busy with continued propulsion testing. Numerous static and dynamic tests were carried out to select an optimal motor, battery, and avionics configuration for both the takeoff and cruise conditions. These tests culminated in a thrust stand being set up on a car to test the propulsion system in a simulated cruise environment of over 60 miles per hour. During winter break, Much of the technical design report was written by the design, manufacturing, and flight test teams. This 60-page report is the most significant factor in scoring the final results of the competition. The report score, scored out of 100 points, is multiplied by the sum of the mission scores out of 7 points. Following winter break, Iteration 2 of the aircraft was manufactured, again in just 3 weeks, this time with a fully integrated subsystem. While the subsystem was tested and smoothed out on the ground, Iteration 2 flight testing aimed to further validate the takeoff performance, demonstrate full-speed Mission 2 laps, and test the propulsion system's endurance for Mission 3's 10-minute stop-and-go flight time. With Iteration 2 already flying on the newly improved wing carry-through design, the team wanted to determine the maximum loads the structure could handle. For this reason, a destructive test of the full wing box structure was carried out. Though it's difficult to see here, watch as the structure is loaded to 122 pounds before failing. This validated the main aircraft structure's ability to fly up to 9.8 Gs in its heaviest configuration, or carry more weight than originally designed. With Iteration 2 testing still in progress, and new design decisions updated in the CAD model to improve the mission scores, Iteration 3 manufacturing began. Iteration 3 would go on to fly in the competition fly-off in Wichita, Kansas. Manufacturing this airframe was carried out over 5 weeks to ensure greater care and quality, and that the final airframe met all competition requirements. Finally, Iteration 3 took flight less than 1 month before the competition. With a wing design validated in the wind tunnel, failed and redesigned structures, proven payload subsystems, a propulsion system tested over the full envelope, and an airframe carefully constructed by 40 aerospace engineering students, the obvious goal of Iteration 3 flight testing was to prepare the airframe and the pilot to demonstrate Mullet's performance to the world. This included landings using brakes and reverse thrust, payload loading and deployment using a fully autonomous conveyor belt subsystem, and maximum speed and endurance tests on a proven propulsion system. Finally, carbon landing gear, custom manufactured in-house, was installed on the wings and the aircraft was ready to go to Wichita. To travel to Kansas, a custom plywood box was built to carry the aircraft and its components. Yes, I spelled Embry-Riddle wrong. Big deal. And with that, 21 of us loaded our bags and headed to Wichita. The 2022 competition fly-off was hosted by Textron Aviation in Wichita, Kansas. Day 1, Thursday, April 21st, began with receiving report scores. Our team placed 17th with a score of 86.77, much lower than anticipated. Next, we set up our pits and prepared the aircraft for technical inspection. Tech inspection served to certify that each aircraft met all competition requirements and was safe to fly. Mullet passed on the first attempt, so the ground mission was next. Unfortunately, the first attempt at the ground mission was not a success because the vaccine vial packages were different at competition than originally presented in the requirements. The requirements depicted a wooden block. However, the competition blocks had been painted with a latex paint to make them more aesthetically pleasing. This caused issues with our conveyor belt subsystem. That night, we troubleshot the issue and came up with a temporary fix. The following morning, on Friday, we attempted the ground mission again. It was another unsuccessful attempt as the payload issue remained to be reliably solved. However, we were soon to be called for a Mission 1 flight attempt, so we shifted to preparing the aircraft for flight. High winds in Wichita certainly made for short takeoffs and scary flying, but Mission 1 was an easy success as the aircraft performed exactly as designed. Following Mission 1, the team continued troubleshooting the payload issue. Later in the day, Dean Gregory from the Daytona Beach College of Engineering stopped by for a visit with the Embry-Riddle Daytona Beach and Prescott campuses. He arrived just in time for our first attempt at flying Mission 2, which we successfully completed by flying 3 laps carrying 110 syringes in 1 minute 50 seconds. Immediately after, we attempted another ground mission that failed yet again, but we were getting closer, and with a little more troubleshooting that night, we finally had the payload issue solved. Saturday brought even more wind. Imagine flying a 12-pound airplane that has a stall speed of 22 miles per hour, in sustained winds over 30 miles per hour, and gusts over 40. Needless to say, we had to think twice about flying and began the day with another ground mission attempt. Finally, we passed with a time of 2 minutes, 43 seconds. A little slow, but it put us on the board. We then prepared for a Mission 3 flight later in the day as the winds began to calm. As we got on the flight line, we were minutes too late before the time was up for the day. That night was spent improving the ground mission time and ensuring the conveyor belt and door slide were safe for the following day. Sunday, the final day of the competition, was a busy one. As the first team to fly in the morning, we loaded 10 vial packages into the payload bay and took off for Mission 3. We deployed 8 and 7 were successful. While everyone in Wichita was blown away by this performance, we knew we could do better. Without needing any more practice, we waited to be called for flight once again and proceeded to load another 10 vial packages. This time, we dropped all 10 and 9 were successful. This was by far the best in competition. Not only that, but we had almost 50% battery remaining after the 10-minute flight, something that baffled other teams and puzzled the judges, while it was flying exactly as designed. At this point, we had a first place score, but we knew the competitors would be creeping up on us throughout the day. So, in an attempt to improve our score, we re-attempted the ground mission. A new strategy helped us shave a minute off our time, but one vial package tripped the 25G sensor upon deployment, which invalidated the attempt. So, there was only one thing left to do: re-attempt Mission 2 for a further score increase. With only hours remaining, we headed back to the flight line and asked for 180 syringes. No one believed us when we said that number because our airplane was smaller than many others in competition that could carry far less syringes than us. While we proved we could fit 180 syringes during tech inspection, only 175 were loaded before this Mission 2 reattempt due to the stress and time constraints of prepping the aircraft for flight. This was it. I ran the numbers, and not only did we have to fly more payload, which was, by the way, 25% over the design weight and 3 pounds over what we'd ever flown before, but we had to fly faster than last time, 3 seconds to be exact. We took off, and the pilot, Noah Pecor, had some of his best flying we'd seen all year. The turns were tight, his flying was smooth, and the laps were fast. I stopped my watch at 1 minute, 49 seconds. 2 seconds too slow. But it was unbelievable to watch. While waiting for the final tally to come in, we hung out on the tarmac to take pictures with the other teams. It was fun to watch the sportsmanship and camaraderie of so many great aerospace engineers wanting to share this experience with one another. And finally, the awards. Our sister campus from Prescott, Arizona placed 8th. Our good friends from FH Johanneum in Austria placed 3rd, and we placed 2nd out of 97 teams. With the best performing aircraft in the competition, we were proud to show off our hard work in demonstrating mullet to the world. We wrapped up with a team dinner at the hotel and headed home to hang the aircraft in the College of Engineering atrium for years to come. Thank you for financial support from the Embry-Riddle Daytona Beach College of Engineering, Aerospace Engineering Department, Office of Undergraduate Research, and various donors through the Office of Philanthropy. A special thank you to Census Technologies in Daytona Beach, Florida, for their financial support in sending so many students to Wichita, Kansas. Check out Census for your beyond visual line of sight industrial drone needs. And last but certainly not least, thank you to all 40 members of the Design Build Fly team for your countless late nights and early mornings in bringing mullet to reality. We learned, loved, and laughed that aircraft to a beautiful performance in Wichita. Best of luck next year, and see you soon.